Good morning, all you positive people. What's good? Today we're going to look at one example, optimization day 2, so that you guys can get started on the classwork and then the homework afterwards. Here's the first question and the only question. I'm going to read it to you, but you guys can stop and read it to yourselves, process the question, and then we'll look at it together. Enzo, get off your phone. Sophia, put it away. All right. A rectangle is inscribed in the region bounded by the x-axis and the curve y equals negative x squared plus 4. What are the dimensions of the rectangle with the largest area that can be inscribed in this region? So right off the bat, we're talking about a region that's described on the coordinate plane, and it might help to draw it. We know it's bounded by the x-axis and this curve negative x squared plus 4, which is just a parabola opening down the y-intercept of 4. So 1, 2, 3, 4 is its y-intercept. You can find a 0, set it equal to 0, which is going to be plus or minus 2. And that is the graph. So the question is, what are the dimensions of the rectangle with the largest area that can be inscribed in this region? So this is the region. What's the biggest rectangle we could fit in here? So the question is, what are the dimensions of this guy? So we're going to call the height y. And we're in the xy plane, so I really have no choice but to call the height y. The length, if it's x by x, I'm just going to call this 2x, so that the x values are really coordinate values, not just like some length. So I want to find out what x is. We'll double it at the end, and we got to find out what y is. But I got to use x, so that's the same x in this equation for y. So just like any other question, we need a primary equation and a secondary equation. So the primary equation is what we're trying to maximize or minimize. So I'm trying to maximize or minimize what? Let's see. The dimensions of the rectangle with the largest area. So I want to maximize area of this rectangle. So the area of rectangle is base times height. The base is 2x. The height is y. But again, we have two variables, so I need to come up with a secondary equation. And I need another equation that relates x and y together, so I can replace the y with something in terms of x. And luckily, they gave us one. It's that top curve, negative x squared plus 4. So now what I can do is take that equation and substitute it in for y in my primary equation. And this is really the only thing new about what we did before and what we're doing now, is that the equation is on a graph, but the secondary equation is almost given to us for free, and we're just going to substitute it in. And the goal now is, once we have our primary equation, we want to maximize it, so we need to take the derivative, set it equal to 0, and find those critical points to where the maxes and mins are. So before I differentiate this, I'm going to distribute the 2x, and so it's a little bit easier to work with. That's going to be negative 2x cubed plus 8x. So if I differentiate it now, the derivative of a, the rate of change of this function, is going to be negative 6x squared plus 8. So I want to find out where this thing is 0 or does not exist. It's going to exist everywhere because it's quadratic, but we can find out where it's 0. I'm going to add 6x squared to both sides, divide both sides by 6. 8 over 6 is the same thing as 4 over 3. Square root both sides, and it's going to be the square root of 4/3. As Zach mentioned last time, it's plus or minus. It's not actually going to matter here. If I put that in a calculator, I got about plus or minus 1.155. So when I plug my value of x squared into this equation here, we can find the value of y. So y is just negative x squared plus 4. And x squared I actually know is 4/3. So I don't even have to put x in and square it. I already squared it. So negative 4/3 plus 4. Let's see, that's negative 4/3 plus 4 times 12/3, which is 8/3. Which is, 2.3 repeating? Nope, 2.6 repeating. So, what are the dimensions? Of the biggest possible rectangle we can inscribe? It's going to be, let's see, the x's, I got to double that. So it's 2x by y. So if I double the 1.155, it's about 2.31 by y, which is about 2 2/3. I'm going to just call it 2.67. approximately. Okay? And that's it. So if you like the video, be sure to smash the like button or ring the bell for notifications. Hey, did you know less than 20% of my viewers are actually subscribed? I know. Crazy. Well, if you like my content and want more, let me know in the comments. I'd love to hear from you. If you want to further support my channel, consider joining my Patreon. It's a great community full of wonderful people. Also, I'd like to thank the sponsor of this video, Raid Shadow Legends. Join today.